All right, beautiful people, let's talk probability. So we have two different kinds of probability that we're going to talk about in our notes section. So our first example says spinner X is divided into 4 equal sections and spinner Y is divided into 3 equal sections. And you can see spinner X is here, 1, 2, 3, 4, and spinner Y, red, green, blue. If you don't like how this looks and you think of a spinner differently, go ahead and draw it. It's not a big deal. So you can see like this is spinner X and it has 1, 2, 3, 4 sections. And then you could come over here and say, okay, spinner Y has those 3 sections, red, green, and blue. If that's easier for you to look at and make sense of, then draw it that way. That's not a big deal. You know what a spinner looks like, okay? They just gave you a different picture of the spinner, and that's fine. All right, so then it says both spinners are spun at the same time. So what is the probability that spinner X will land on 2? So spinner X will land on 2. And then spinner Y will land on blue. And the key word here is and. These things are happening at the same time. So we're actually going to have a fraction for spinner X and a fraction for spinner Y. And because it says the word and, we're going to multiply our 2 fractions together. All right, so again, X is going to land on 2. So how many 2's were in our spinner? There was 1, and there are 4 total sections of that spinner. All right, and then for spinner Y, we had landing on blue. Blue was 1 color out of 3 total colors. And then how do we multiply fractions? We just multiply top times top, bottom times bottom. So 1 times 1 is 1, and 4 times 3 is 12. And again, keyword here was and. So that's the big factor I want you to remember. And means we have 2 separate fractions and we're going to multiply them. Okay, and was our keyword. So we had 1/12 is our final answer. 1/12. All right, so the second example that we're going to talk about is the word or. So up on top we talked about and, so now we're going to talk about or. So it says a deck of cards contains red, blue, orange, and yellow cards. A card is drawn and then replaced. This process is carried out 40 times. Okay, 40 times. The results are shown in the table. So basically they already told us that the total of this table when I add it together is 40. So I'm gonna write 40 and I'm gonna label it as the total. And again, I didn't have to add because it told me up here that this happened 40 times. Again, I have 4 different colors, red, blue, orange, and yellow. All right. Keyword here is probability, just like it was up here, probability. And we know when we see the word probability, we are going to create a fraction. So when you see the word probability, we know probability means fraction. Okay, we're immediately going to make a fraction, and we know that on that fraction, total goes on the bottom, and whatever they're asking for goes on top. All right, so both of these are going to be fraction problems, just like on and up here. All right, so it says, based on these results, what is the experimental probability that the next card drawn is red or orange? So when it says the word or means to add. So we have 1 fraction for this problem, 1 fraction, but because it says or, we're going to add those 2 things together. So we are going to take the red and the orange, and we are going to add them together. So 9 and 13, because it said the word or, we're adding 9 and 13 make 22. 22 is our red and orange combined. Red and orange combined. Again, why did we combine them? Because it said the word or. So this problem is our or example. Okay. Up top, this was our and example. All right, so again, 1 fraction combining red and orange together to make 22. So we have a total of 40 and 22 of them are red and orange. So that's my fraction, but the question says so that's what is the probability of red or orange. So we found the probability of red or orange, but it doesn't match any of my answers. But what I can do is I can eliminate Joe Schmoes. So I can clearly see that 22 over 40. Well, my 40s match, but the 22 and the 13 don't. So this is a Joe because we can't have one part of our fraction match, but not the other. Okay, same thing for D. If I write 22 over 40 next to it, the 40s match, but you can clearly see the 9 and the 22 don't. So that is a Joe Schmo. So now it's between B and C, and I can see that one is 1/2 and the other is 11/20. So I got to figure out which one is equivalent. So you have two options for seeing if these are, well, three really. Three options for seeing if it's equivalent. You can butterfly your answer with their answers, right? So we could say 22 over 40 next to both of these, and we could butterfly corner to corner and see if they come out equal. You can also simplify, so you can say, oh, what number can I divide out of 22 and 40? And remember, we like to use the 2, 3, 5 method. So I ask myself, can I take out a 2? And the answer is yes for both the top and the bottom. 22 divided by 2 is 11. 40 divided by 2 is 20, and we can see 11/20 right here. Again, I could prove that further by butterflying corner to corner. That's always a good option. So if I said 11/20 and 22/40, and I multiplied corner to corner, both of these are going to get me 440. So that proves that. You could also turn it into a decimal. So you could cowboy and horse divide and see which one matches. So three options for simplifying. All right. And so that is OR. So those are the two different types of probability problems I want you to focus on. Is it asking for this and this? Because if it's asking for this and this, that is two separate fractions. The first thing and the second thing, and we multiply. The second one is OR. When it says red or orange, or two things, this or this. When it says or means to add. So again, we add those things together and we make one single fraction. And then from there you can simplify if needed. So that's the big difference between and or. All right, so let's go down here to our prove it star question and let's read our statements at the bottom. When we see the keyword probability, we should immediately make a what? Well, we're immediately going to make a fraction. And with that fraction, we're going to put total on the bottom, okay? And then we learned that OR means to add the numbers and make one single fraction, while AND means to create two different fractions and multiply. So that is the big difference between these two types of problems. And when we multiply top times top, bottom times bottom. All right, so go practice your prove it star question here and really think about, is it an and problem? Is it an or problem? What are we looking at? Is it an or is it an and? All right, and then remember, probability always means fraction, total on the bottom. All right, go practice.